Just there we go. The recording's there. Share screen. Perfect. So welcome to our fifth tech training session with the hot data and tech team. So we are conducting this session every Friday of the week. We are currently at our fifth session. As you may see here, we let me just share my slideshow. Oh, it's not sharing the whole screen. Can you see my screen? Well, Shitij? No.
Yeah, we can see your presentation though.
Is it in like portrait mode or something? Or is it
Yes,
okay?
it is in portrait mode.
Yeah.
Correct.
Yeah, I think I'm still figuring out how this works. Let's try this again. Okay, anyway. So as you can see here, there's like going to be 7 trainings that we're doing. So we're already done with the other 4. We're moving for April. We're doing 3 more, which is accessing and visualizing open map data. The 6th one would be introduction to basic QGIS analytics. And the 7th one would be QGIS for specific use case scenarios. So we're focusing on some use cases on flooding, landslide, and land tenure. So it's a as you can see, the trainings that we've conducted is pretty much uh, use to use case. So we started way back in March about collecting and sharing drone imagery. So we would want that uh, use to start with how do people collect the imagery locally through drones, etc. Sometimes through satellite imagery, and connect it to different and various ways that we could fill in the map data towards it. As you can see, there are several ways wherein people can contribute through OpenStreetMap, open mapping tools, etc. You can do remote mapping. Some of us focuses on filling in more gaps through local mobile mapping tools or field mapping tools. And then, of course, these data from drones to remote mapping to field mapping tools, the data that we put into OpenStreetMap gets to be used by people on the ground, like doctors, logisticians, first responders, because the information we're putting, not just buildings, not just roads, hospitals, etc., but all that information help the decision makers to make more critical decision that can save lives and better the lives of people on the ground. So I go back to this slide wherein you can see that we've gone through drone imagery for remote for mapping. We've shared how different open mapping tools like ID Editor, JOSOM, Tasking Manager, and MapSwipe for web can contribute through remote desktop mapping. We also have AI also, and how it's being done in an open and ethical way the through FAIR. Last month, we did a session also on individual and coordinated mapping using field mapping tool. So as you can see, we're trying to cover all grounds. And today, and this day, we're going to highlight when the tools are already in OSM, how do we access those tools and how do we visualize those that data for people to make those decisions. So I'm going to be passing the floor to Kshitij and Aditya in a few seconds. And I hope everyone has a great day behind them and feel free to relax, ask questions. And again, I'm going to say your questions, please put them in the chat box. And I will be sharing those questions to Kshitij and Aditya later on. Kshitij, are you ready?
Yes.
Okay, let me just stop presenting and the floor is yours.
Thank you, Miko. Okay. Give me a second. Can you see my screen?
Yes.
Yes. Perfect. Okay. Uh, is it? Can you read the information shared on the screen, or do you want me to maximize it in a presentation mode?
For me, I can read it pretty clearly, but
Okay.
maybe Yeah, maximize. Yeah, request from people to maximize.
Okay, perfect. So I'll enter in slideshow mode, and so I'll try to make this session as interactive as possible. Like I will be doing a couple of demos, navigating the links, where to find the resources said during the presentation. So yeah, I will be going on and off in the slideshow mode. Okay, so let's just start. Hello everyone, I'm Chitish. I'm based in Nepal. I work as a product owner for Map Data Access Services in AutoSM. I'm with AutoSM since past couple of years. I think it's been more than 2.5 years. And currently I am involved in project called Expert Tool, which you will be hearing about later on. And also like the data sets that are currently being pushed in Humanitarian Data Exchange, SDX, also included. And I also work on tool called FAIR. So you probably are familiar with it. It's a free and open source AI mapping tool, which we had a session before with Omran, as Miko mentioned. So yeah, I'm also responsible for raw data API, and I like keeping my hands dirty here and there. So alongside with me, I have my wonderful colleague Aditya, who will be talking about how to visualize the data in different tools. So I won't reveal the tools. You will know later. And let's get started. Okay, and I'll also please feel free to I'll also leave some time for questions so that we can address them, as Miko mentioned. So let's dive in. Accessing the map data. So since you already know so far how we collect the drone image, how we also process them, and how we use for humanitarian data responding, but not limited for sure. But by the end of the day, when you produce them using collaborative mapping tool like Tasking Manager, Field Mapping Tasking Manager, right? We collect the data from field, but how do we access it? We need the data by end of the day. And I will be starting with the concept note first, which I will try to explain how elements in OpenStreetMap works. So not limited to OpenStreetMap, but I will start with first OpenStreetMap. So this is OpenStreetMap data structure. You are probably familiar with it. There are nodes, ways, and relations. There are three main types of OSM elements. So nodes are basically used to define points in a space. They are basically a points which consist of latitude and longitude, right? And also it's a node ID, which is a unique identifier for each node that is created in our OpenStreetMap space. So let's say if you are defining point of interest, right? Or if you need something to represent for your health facilities, for your educational facilities, or the drinking waters, amenities, those can be defined as points. Points do not only consist of features, it can be used as a references. When I say references, let's say, let's jump into the ways first. If there is a building, right? Building consists of 4 points. Let's say, in a way it works in OSM. If you define a building as a way, because basically area is a way, I see in chat as well. Area is a way. Way is basically a collection of the points. You just bind them, stitch them together, make sure that each, if first point of the polygon is equal to last point, if first point of your string is equal to the last point, then it is polygon, right? It's an enclosing polygon, otherwise it's a line string. So ways divide into, it could be line string, it could be polygon. It will, as defined in a presentation, it's a linear feature and the area boundaries. It can represent buildings into ways, you can represent roads into ways, and rivers into ways. Relations. So what are relations? Relations is like how, let's say, if we define points, we define ways, like we define roads, how they fit into together. Let's say, what is the relation between them? What if they fall into, let's say, relationship under sharing the same namespace of an organization, right? If it's a either it's a island, either it's a province, either it's a district, everything falls inside the district. So mainly to determine geographic relation, or it could be logical relation between different objects that we just talk about. It could be nodes, it could be multiple ways, and they can be referenced into relations. As I gave example of, it could be a district boundary, it could be island boundary, or like it could be simple let's say administrative boundary of the school. So relation features are used to determine the relations between, like establish a relation between features. I'll recap: nodes, point defined in a space; ways, basically nodes, but they are connected with each other. If the first point equal to last point, considered as a polygon. If not, it's a line string. Not only line string, there is also concept of, like, let's say, multi-line string. It can go from basic to advanced. Polygon can also be expanded into multi-polygons, but ways are responsible for both line string and polygons. Relations, it could be multi polygons. When I say multi polygons, let's say a single boundary, a single school administrative boundary can have multiple buildings inside of it, right? They can be referenced in a single school boundary. Same goes for the line string. It can have multiple line string. Same goes for the points. It can have like multiple points. This is the basic concept on OSM data structure. What I tried to explain here is how this OSM data structure translates into GIS features, into point, line, and polygon. So when you say, like, this will be very important when you run overpass query, you will know what to query for. If you are searching for drinking waters, if you are searching for points, then you might want to query nodes, right? If you are searching for the hospitals, but you just want hospitals which are tagged in an area, in ways, buildings maybe. So you might search for ways. If you are searching for a traffic route, then you might need to, routes are basically relations, right? Relations of the road. So you might need to search for the relations. This is the concept how OpenStreetMap data is structured and how you can access them, and it will be useful in the next sections. So first step, I want to start with how you can process OpenStreetMap data by yourself. If you have, if you are equipped enough with your command line processing skills, or like you know a bit of programming, or if you're not afraid to run some command lines and you want to do advanced analysis, then OpenStreetMap can actually give that there are multiple formats the way OpenStreetMap data is served, and then you can use them in order to process by yourself. I will pause here and I will showcase how, like, OSM is like transferred into node ways and relation, and then I will explain self-processing section. So this is OpenStreetMap. I hope my OpenStreetMap is visible. Mikko, can you confirm that? Or Aditya? Yes, okay, perfect. Thank you.
Yes.
Okay. So I will showcase a couple of like node ways features. Let's say in this area, we have a node, which is tagged as an office government. If you click on download XML, which I will be talking about later on, how this translates into ASM XML format, this is node, right? I'll also simply query some building to showcase the ways. This is way, and as I said, ways is basically a collection of nodes. Look into the nodes that are connected in order to construct this way. So OpenStreetMap itself does not store the wedge geometry directly because they are basically references. The ways are referenced into those nodes, and then it will connect it one by one, and then it will enclose. If they are enclosed, it's a polygon for us. There are multiple ways the way it stores the geometry, but yeah, like the basic concept is ways are a collection of the nodes. So it will create multiple nodes and connect them. Now relations. Let me see if I can find some relations. Maybe probably some university boundaries. That would be neat. Okay. This is building. Let me see if we have relation here. Here we go. No, it's actually a polygon. Okay. Let me see. Maybe we have some lakes. This is actually area of my hometown. So yeah, we have some village. Okay, this is village boundary. So this is relation. If you look into the relation, it has 6 members, right? This is one way member, is a outer member, and then it is also part of the bigger relation, which is a municipal boundary. Since it's a ward boundary, it falls inside the municipal boundary. So this is how relation works. Relation relate to the features, try to like um, showcase logical or geographical connection between features. Self-processing. What are XML files? What are PBF files? SQL and Parquet. I'll be talking about those 4 files, but not limited to. First, I'll try to quickly explain what they are. So XML is it was developed a while ago. It's basically a text. Like initially, it was developed as a text, but since it can it's a human readable format, people can easily read what XML format is, and then it can also be used in, let's say, very low level softwares. Like you can easily interpret them, you can easily have some scrapping methods to extract the data out of it, and it became popular in OSM universe. So OSM currently, not only the API, but also OSM currently dumps, let's say, replication files. When I say replication, the way OpenStreetMap works, it creates a diff file, so differential files every minute, or there is also frequency of every hour. So what happened in OSM this minute will be bundled up as a diff and served it to the rest of the other softwares who want to use it. That's how OSM ecosystem works. And during which XML is very popular. XML is being used by OpenStreetMap. By OpenStreetMap API, not limited by only OpenStreetMap. You can find XML in rest of the other softwares as well. But yeah, XML, one of the widely being used. And I'll also showcase later on, after this slide, how XML is formed, how you can interpret XML. So if any of you wants to have some simple Python script that can go to XML, extract some information and come back, you can do that. And you can extract your data by your own custom script. So planet.osm is, I also attached this link, is very popular. You can see multiple replicas of planet.osm in OpenStreetMap wiki, from where you can download the diffs that I talked about. Not only diff, you can download whole OSM data of the world in PBF format, BZ2 format. I'm not mentioning BZ2 here, it's a compression technique, but I will mention PBF. So what is PBF format? PBF is protocol buffer binary format. Mainly it is like, since I say XML is very good, very popular. Like, I mean, I love XML, but if you want to serve data of whole world or data of whole Asia, then XML would be super huge. It's a text, it's a series of text that is human readable. But we like OpenStreetMap, when serves the data of Asia, wanted to have some format that is like smaller. at least like it's a compressed format, and it can be served to users so that they can interpret it by themselves, and then we'll at least like save huge amount of network cost, huge amount of processing cost. So it is primarily intended as an alternative of XML. Why? As I said, it would be bigger, so that we want some compressed format, and then PBF file itself, file format is a compressed format. And then, like as I mentioned in the slide, it is half of the size of the gzip planet, and also 30% smaller than the bzip planet. So if you are not aware of gzip and bzip, those are compressed format. You can look into this, very popular in, let's say, compressing text, compressing images, and PBF itself is a compressed format. SQL, so that's why, like, you might notice when I showcase later on where you can download the data for your processing on processing script, you will notice .pbf formats. Third is SQL format. Since it's not been that much since Postgres introduced PostGIS extensions, and PostGIS extensions are becoming very popular nowadays, especially for the special query due to the range of the query that PostGIS supports, the range of the functions. It's incredibly powerful with Postgres. And since OpenStreetMap, as I mentioned before, OpenStreetMap works in node, ways, and relations, but it does not work in a direct sense the Postgres understands, right? We need a table. PostGIS need to have a geometry in it so that it can perform some PostGIS functions, right? So it is not a native PostGIS. It is not in native PostGIS format, but people, since developers figured out power of PostGIS, like it's super good. QGIS is becoming very powerful nowadays. It also supports database connection, and most of the functions in QGIS is also available in PostGIS. And so yeah, people wanted to convert OpenStreetMap data into PostGIS native format. So there are multiple ways to do this. There is one tool called OSM to PGSQL that can convert this PBF formats of file into Postgres database. It can like dump it into Postgres database, and then you can share the data using SQL, .SQL. You can share it, you can query it, you can do, we'll also like, I'll also perform quick demo for this. But yeah, SQL files is becoming popular. That's why I wanted to mention this. And recently we had a deployment in Expert tool, which also provides you the .SQL file directly so that you can get it, put it on your Postgres. And if you are very efficient in database, you can query it. You can run your own queries, custom query analysis. Field Mapping Task Manager also runs very advanced task splitting algorithm in PostGIS. So it's basically loads OpenStreetMap data into the PostGIS database, and then it runs algorithm for the task splitting, right? So SQL files. Next is Parquet files. Parquet is recently single file database system. Why I love Parquet? Because Parquet can act as a database. It's not a database itself, but you can query Parquet files directly from your file system, right? And it is very efficient in storage. It's a cloud optimized file system. You can retrieve the data from Parquet. Let's say if you have Parquet file of whole Pokhara, like let's say whole city, and then if you want just small part of it, you can simply query select asterisk from my city.parquet for this area, but I just want rivers from it. I just want buildings from it. And it becomes extremely efficient in order to query the data. And since like Parquet also works on column oriented format, so you can have where query would be very efficient. Let's say I want only buildings which has attribute, let's say amenity. Amenity is equal to health services, or like some other queries in OpenStreetMap that you want. One more thing, like OSM data, you might not get OSM data in Parquet easily nowadays, like, but there are some softwares that is looking to produce Parquet files. For example, in OSM Expert tool, Parquet file is something we are working on so that people can get OpenStreetMap data in Parquet format. And if you are not aware of DuckDB, like DuckDB is extremely powerful that can load Parquet files in one or couple of commands. And overture map data, which we will be talking about by in end of this slide, it is also available in Parquet. So I want to quickly showcase how you can read XML files in OpenStreetMap. I will also showcase where you can get PDF files. I'll cover SQL files in the rest of the in the export tools section. Let's just start with XML files. Sorry about my dog. Dog is barking. I hope that's not much of a problem. Let me showcase what XML file is. Actually, so what I did before, I did some mapping a couple of days ago. Say, okay, I did parking lot and security post in this area. Now, it contains 2 ways and 13 nodes, right? If you want to know, like this would be important if you want to process the OSM data in order to get the data into the useful formats or formats you want. Then you need to understand this XML, which is if you click on OSM change XML, it's probably my ad blocker. Let me bring out another browser. Perfect. So this is one XML. This is how OpenStreetMap data serves diff in XML, right? If you look into the XML, it is saying this is OSM change, what I did change on this, change that. It provides what user is, and here are the individual nodes. This is the action. So it says, I created this node, this ID. I created this ID. It gives me latitude and longitude. And so it can be accessible directly from the OpenStreetMap API. So that's why I'm saying like self-processed data is you can have a Python script, or like any script in any language that you are proficient in, and then you can directly scan this XML and construct the points. I'll also showcase how ways are constructed. When I said before, Waze itself does not have geometry, right? It's basically reference to the node so that later on processing software can build geometry out of this. So OpenStreetMap provides Waze in a fashion like this. It is saying, I created this way. This is my username. And this way is tagged as a highway and value as a steps, right? And it says, this is the node reference. This is another node reference, 1, 2, 3, 4, 5. I have 5 node reference. If you search this node, it is also referenced in another footway. That means those two are connected. And you will get this node latitude and longitude here, right? Here, you don't get whole geometry of the ways or polygon I created because OpenStreetMap works on node, ways, and relation. But later on, they will be translated into point, line, and polygons based on those references. So like, let's say overpass, and we also have a tool called underpass, or like other processing of scripts. I think Osmium, they do all the same thing. Is they will try to find the references. They will go into the references. They will pick latitude and longitude of each node, and then they will try to construct the geometry out of it using these references. So we'll have geometry for the highway, correct? This is how OpenStreetMap works. So yeah, that's quickly I wanted to showcase how XML also works. And let me close my screen, come back to the training, PVF files. I also attached this planet.osm. I wanted to mention this because it is a very popular directory, which contains multiple files that you can download. This is the original source, but sometimes source can be down. You can like have some replica, like there is a replica running in Russian server, there is a replica running in France server. So yeah, If one is down, you can get it in another. And then it says like, what's the frequency of the data that is being updated in those replica, right? In Russian server, like you can get minutely updates. In France server, OpenStreetMap France server, you can get minutely updates. And you can also see what are the type of the files that you can get in this area. Does it have support of IPv6? And those information can be available here. I'll showcase how this files sharing Planet OSM works, file sharing system in Planet OSM works. So this is Planet OSM, where you can get XML files that I just talked about. You can get every minute, you can get every day, every hour. I think that's the frequency. Let's say when I say replication means like it will update every minute, like it will capture the every minute data, or every hour, every day. Currently, those are the three frequencies available. Let's go day, and let me showcase some data. So it has GZ format. This is a change file. If you download it and if you unzip it, you'll get the XML file inside of it. Let me save it. Hopefully it's not too big. And then if you open it, you will get multiple .xml files, and then you can have a script to listen to this, and then you can provide a data or geometry out of it. Not only that, what I wanted to showcase is PBF. Let's say if you want to process whole planet data, right? If you're interested in a planet, you want to experiment something, you want to get all the trees available in Asia, all the trees available in country Nepal, or you want to clip out or do some analysis on, right? You can download planet data from this. Like you can download the PBF, you can have your script or software process this, get it in PostGIS, create it in, or like in your format you like. That would be possible from this link, right? Let me see if this is downloaded. Perfect. Yeah, so if you open this, I'm not going to open it, it's pretty heavy, but if you open this, it will be in the same structure that I explained before. And same goes for a PBF is completely different format for sure. It's a optimized compressed file format. It's a binary protocol format, basically. You can process it as well. So Planet OSM directory, where like you can get those PBF in planet level, or minute level, hour level, or daily level. Let's say one simple use case. I wanted to analyze how users in OpenStreetMap are like, what are they doing every day? Like, let's say if today they are focusing on field mapping, where are they focusing on? Which country is more popular? How many people are contributing to this hashtag or something? All this information, all this map data information that you can access from this, let's say, daily format. You just download previous day, all the XMLs, or like all in PBF if you want, or diff file, and then analyze it. Okay, those are the persons who contributed this day. Those are the persons who created those buildings, or X amount of buildings created in this area. Or you can have like data quality check also. I think, is there any data quality talk? But yeah, like if you are aware, there's a feature coming in Document Manager. We are doing data quality check, and this is how data quality check also works. So you can get every type of information, not only spatial, but like it could be different. It could be data quality information, it could be statistics, like any type of information from this PBF. And OpenStreetMap, like that's a major advantage of OpenStreetMap is anybody can build their own tool on top of it and type do analysis on top in the way they want, right? Okay, I'll move to next, which is Overpass. I wanted to introduce you the tools from the rest of the slides now. Will be targeting you to introduce what are the tools that are available. What if you don't want to process the data by yourself, right? You just want to access the data. Okay, I don't want to process the data. I'll just get the data in a way it is in a useful format that I want, right? So Overpass is widely popular API. It's a basically API designed specifically for data consumers, those who want data, right? It is designed specifically for the data consumers. Is I defined before. I also showcased one API before, which is this one, right? Where I downloaded XML. The diffs It is different than this. This is OpenStreetMap API. It is different than Overpass API. Overpass is mainly targeted. It's a read-only API for data consumers, so that they can directly get the data out of OpenStreetMap. Basically, it acts as a database. It acts as a database over the web, where you can, from your browser, you can suit, hey, I want hospitals in this area. I want buildings in this area. I want buildings which has following X comma Y tag, right? Or it supports, the good thing about Overpass, it supports wide range of custom query. That's a very powerful thing about Overpass, is it supports wide range of custom query. One, I will say, it would be a little bit downside. There is a learning curve involved in order to learn Overpass, because it has its own query language. So it is not SQL. It's not if you're familiar with SQL, it's not SQL, but it's not like a simple, let's say, JavaScript filter or query. It has its own query language. You need to know how Overpass query language works. Once you are familiar with Overpass query language, then you can do query by yourself. And that is good thing about Overpass is there are a lot of tools which are built on top of Overpass API. One is very popular Overpass Turbo, which my colleague will be also mentioning about on second phase of the session. And there is also one tool called Quick OSM in QGIS, pretty popular. People use it to fetch OpenStreetMap data directly in QGIS, probably will be mentioned in QGIS training. So they all use Overpass API underneath, and then they can build so there are softwares which builds on top of Overpass API. And you can design your own software if you like, or you can use Overpass Turbo directly, or nowadays I think LLM like ChatGPT, Cloud-A, or they can also produce Overpass query from you. I'm not promoting them, but there are some also open source LLM that can produce Overpass query, and that can maybe reduce the barrier for you to learn completely new different query language. And there are some nice examples too. It's not that super complicated. So I also attached one screenshot here, which is our Overpass Turbo screen, and it has a query called I'll just explain this query first. So it's a very simple and basic query that I wanted to explain. In this query, it says node amenity is equal to drinking water. So if you are saying why this is in this format, because this is what I was talking about Overpass query language. Sorry, Overpass query language before. So I am saying here in this area, bounding box, which is my screen, I want amenity, all the features in node, right? In the node, the OSM element, remember that I talked about before. In node, I want those features which are tagged as a amenity is equal to drinking water. And I want to out them as a BP box, so that it will give me all the amenities which has drinking water tag. It will also give me the XML format if I want, the XML that I just explained before. And you can construct the geometry out of it, display it in a map. This is what Overpass Turbo will do, right? Or if you don't want to use Overpass, you can still run it in your Python, because it's an API, right? Because it's the API. I'll showcase how to use API in Google Colab. Probably I'll also open Overpass Turbo. So Overpass Turbo is a visualization tool that uses Overpass API underneath. And then what you need to do, you can also load, let's say mountain in the area, cycle network, load examples in Overpass. So it will have some preset. You can find them in the wiki, Overpass wiki. You can learn about the query let's say I want to run it, and then it will quickly visualize the features, and you can go there. I'll leave the visualization part for now, but I just wanted to explain how Overpass query works. Here in my Colab, look into this code. It's a Python. This is my Overpass API URL. It's a similar query that I just show you for the drinking water. Let's say I want everything in this area in this way. I want waste features, let's say, and then I'm sending it using Python request. If you send this, it, since it's a API, it should work as API, and then you can use it. I just got a response, which is this one, right? So it has tags, it is type, ID. Also, I have bounds, so you can also translate it into GeoJSON, display it in a map if you like. So this is how you can access Overpass API. Correct? I'll move to next. GeoFabric. So GeoFabric is a free download server. It's basically a download server that has data extract in different regions. Remember in Planet OSM, what I said? It has data for whole planet. It has data for every hour what's done in OSM, every daily data what's done in OSM, or it could also provide a minutely replication file. But what if you are interested in your own country? I just want to download the data for my country and then I will process it. Or you can process, let's say, no, I won't process it. Maybe I just want to have it in a save file format so that I can put it on my GIS. I will do rest of the stuff by myself. Just give me everything in my area in save file, and then I will do filter. Like I will do filtration. My computer is okay performance. I have some good spec. Then you can probably load it in your QGIS, do your stuff, right? So GeoFabric is the one tool that can provide you customized data extract based on region label. So it can give you Asia data. It can give you countries in Asia. So you can actually download your country data. I think in bigger states, let's say in US, it also gives some state level data that you can access, but it gives in different format. It can give you in .pbf that you can use to process your data. I'll also showcase later on how to process data by yourself. You can have it in shapefile, and you can do rest of the process later on, do your filtration, but it will give everything. It will bind everything into shapefile and dump it in a shapefile. And good thing about GeoFabric is most of the data sets updates daily, usually, but not sure. Sometimes it takes a week, sometimes it takes 2 days, but yeah, like they are pretty frequent. It can give you in .bz2 format also. It also it is easy to download. You don't need to log into the data server. If you are logged in, you will get user information. If you are not logged in, they will still give you the data without removing the user information. But it is very easy to navigate. But one downside of this, extra processing might be required, right? Let's say if you are getting everything in a save file, then you might need to filter by your own in QGIS. Or like if you are getting PBF for your country, you need to still process it. And good thing about GeoFabric, it also provides daily update in region level. That's the main difference between Planet and this GeoFabric is it can provide those diffs in region level. So actually you can have some script listening to your country only, right? So this is the URL that I also mentioned here. So I also attach a screenshot of Asia because that's the region we are interested in right now and where I belong to. So I just attached screenshot of Asia. But yeah, you can get rest of the stuff. I will quickly show you how to navigate in GeoFabric server. Okay, let's say, so if you look into this, Asia has 12 gigabyte of data, which is osm.pdf. So Antarctica also has save file, but Asia does not have save file, so you need to mindful what is available, what is not. Let's say for Afghanistan, we have 95 MB of OSM PBF. It is also available as a save file and BZ2, right? Let's say what is available for Nepal. If you click on Nepal, and then you will see what are the data available. So it says that there is a .poly file, there is osm.pbf, and there is shp format. So I can download shp. It's a file size of nearly 1 GB, and it was updated 10 hours ago. So you can download them or you can process them. This is GeoFabric. Now we move to OSM Expert Tool. So OSM Expert Tool is also an open service that creates customized extracts. What if now there could be question? I explained about how to download whole planet data, right? How to download daily data or weekly data. I also explained how to download country level data from GeoFabric. But what if you are just interested in your region? You are just interested in your custom area. Like it could be some administrative boundaries of your city, or you can simply draw it. Okay, this is the area I'm only interested in. I'm not interested in the rest of the whole process, like whole Nepal or whole country. Then OSM Expert tool is the tool for you. The good thing about OSM Expert tool, it updates every 2 minutes. Sometimes you might face 5 minute or 6 minute lag. Otherwise, like it updates every 2 minutes. It can create customized experts based on the category. You can actually say you don't need to learn overpass query for this. It is simple UI, easy to use. The main purpose of the expert tool is to reduce the learning curve that let's say overpass has, right? Overpass can create custom experts for you. Like overpass is also capable to create custom experts based on your area of interest, but it will try to minimize the learning curve that Overpass has. And it provides a nice UI. You can go there, say, I want buildings in this area, or I want road in this area. I just want administrative boundaries in this area, and then you just click on it, click on expert, and it will give you the expert. It supports massive GIS file formats, different GIS file formats. It can give you the data in GeoJSON, can give you the data in save file. It can also give you the data in KML. So I'll also showcase what are the file formats needed. Downside of the expert tool, it does not give you the, like I say, what if I want only the roads in my country, right? Or like it has some area limit that has been expanded recently, but still it has area limit. You cannot export your whole country using expert tool. But like there are multiple ways to do that. There is also one tool called humanitarian data access. I already explained GeoFabric, but there is humanitarian data access platform where expert tool pushes the data, country level data, or disaster related data in SDX2. So there are ways to access it, but it is not directly accessible for general users in expert tool itself. So if you click on it, this is expert tool, right? You need to log in, log out for sure. And if you look into this, IMZ, PVF, and OVF updated 4 minutes ago, and rest of the other formats updated 2 minutes ago. Why those are two different, I will explain later on, because expert tool uses different backend now. It used to use Overpass before, but Overpass also has some restrictions on the area. You cannot extract bigger area with Overpass server until and unless you host it by yourself for sure. But yeah, those are the file formats I wanted to showcase you. GeoJSON is available, save file is available. You can also, if you love GeoPackage, I absolutely love GeoPackage actually. You can use GeoPackage only if you're interested in. There is a new format we deployed, which is Flat GeoPuff. We are currently working on Parquet file. There is a CSV option for if you are a data scientist, you do not understand much spatial info, but you still want data. You can export it using CSV so that you can apply your CSV analysis skill. SQL. This is back to the same thing. If you want to process this OpenStreetMap data, put it simply in your PostGIS and do your stuff. Maybe build some API out of it, build some WebGIS out of it. You can still do it. Download the SQL from here, and then you can play with it. MB tiles. It is very good for visualization, especially if you have a bigger area. You can serve it as a vector tiles. There is Garmin IMG format. It's an old format to support Garmin enabled GPS devices. But yeah, like Maybe nowadays not that popular, but it used to be at one point before. There is OSM.pbf format. So as I said, it can create a custom PBF. So if you want only PBF for this and do your processing by your own, you can do that, right? You can also export it in OSMN format, put it on your OSMN so that it will be available offline. But OSM is also available in offline. It is pretty old format though. So those are the file formats currently available. You can select, okay, I want buildings, or you can say, I want only administrative boundaries, or I want only road. Then you can search for road, right? And then select road. So whatever you want. There is also one feature where you can download everything, right? So it will export everything, dump everything, and then you can create the export. OSM export tool, good thing about export tool is you can quickly pick into the data without exporting it. Let's say if I want buildings in my area, in this area, this is my city, and then I simply select this, I want building, and then it will quickly say, okay, it has 5.6 thousand buildings, so that you will have some rough idea how many you are going to export, right? So we created one expert especially for this training, which is this one. Uh, so it took us 2 minutes to export everything, and you can download them later on. Our colleague will also showcase how to visualize this data. But if you are familiar with GIS, just download the GeoJSON or KML, save file, whatever you want, load it in your GIS, and then you will be able to visualize it, right? Or any other visualization software. I will leave this part right now. Okay, so you know about Expert Tool now. What next? So Expert Tool, one thing I missed here is like it's very useful for the people who do not like. Let's say I don't want to know about whole load pass query thing, and like overpass has some limitation. I don't want to go through that. I want to expert bigger area. I want a simple UI. Then Expert Tool is the tool for you. What if you are a developer, you want to develop something out of it, but it's still like the same, you want to also overcome overpass incapabilities and then build something on your own, then raw data API is the one for you. So what is raw data API? Raw data API is just set of couple of high performant APIs that is designed to be performant enough to extract OpenStreetMap data in different GIS file formats. So it's unlike other tools. It does not have query language in itself. It is very reliable. It will put you in a queue if system is very busy. You need to wait for a couple of minutes maybe, but it will get it done and it will send the response back. So expert tool, same goes for the expert tool, but it will email you once expert is complete. It is mainly useful for the developers. Export tool uses raw data API as it is a backend for all the formats except those three: IMZ, OPF. We are also planning to work on PBF right now. Um, but rest of IMZ, PBF, and GART, rest of that, everything is coming from raw data API right now. It is useful for developers, as I said before, but it is a normal JSON payload. You can say, I want the data in this GeoJSON, and then you can use it as a rest of the API that you're used to. If you are a developer, you'll understand what I'm saying is like it's a normal JSON payload, but it does not have a UI itself. Expert tool is the one that uses this. Expert tool is the UI, but it does not have native UI. It's built in on top of Fast API. If you wanna like quickly explore the documentation, maybe give it a shot, you can do that using here. So you can go there, log in. It works without login as well. So yeah, one thing I also wanted to show you is maybe bit of a hands-on. Let's say this is my payload. In this visualization, I want buildings. All the geometry that has building is equal to yes. It does not work on node, OS, and the relations. Like you don't need to know about it. You can simply say, I want points, I want polygons, and then it will give you point and polygons. So it should be straightforward. And then yeah, like you can get it. I will quickly send one request to raw data API, and then I will visualize it in GeoPandas data frame. Right. Okay, so I got 2 points plenty of polygons. So I extracted my this area of city, right? So it should be very quick. And as I said, it is a high performant API uh, that you can use. Yeah. Next, what next? Next is Overture datasets. So I wanted to touch up about when we are talking about open data. Overture Maps is also released recently. There is a foundation called Overture Maps Foundation. It is a joint development foundation. It was like the main goal, according to Overture, describes to share open data across whole the globe. So not only OpenStreetMap data, like it will contain extra data as well, but it is also targeted for developers who builds map services or who just want to use your special data, but also have a couple of developing skills so that they can play with data. It does not have native UI by itself, like OpenStreetMap does, or other UI have, but uh, it shares the data in Parquet format. Remember the Parquet format I told you before on the first slide, right? It also shares data in a Parquet format. You can use DuckDB to convert this Parquet format to maybe GeoJSON, save file, or any other maybe vector tiles, use MB tiles, PM tiles, and then display it or load it in QGIS or any other visualization softwares that you want. So I attached a snapshot of the code that I used so that I can simply extract Overture map data and then quickly visualize it. So I used DuckDB for this. DuckDB is, those of you who do not know about DuckDB, DuckDB is a powerful file database system that can work on simple file system. It does not need a native processing database engine, but you can do query and everything. Parquet is ideal for DuckDB. It can support Parquet directly. So I attached a link where which explains what is the schema Overture map data uses. It has currently, like as you say, it has transportation data, it has places data. It recently also released buildings data. So those are all data sets that you can use. For sure, you need to understand how licenses works in Overture. But yeah, so far, those are the things available. And then you can download it. Like there are plenty of discussions, plenty of tutorials how you can use it. And I also, as I said, I also provided a snapshot of DuckDB, how you can copy the Overture data into DuckDB, and then you can convert rest of the. Currently, it is converting into GeoJSON sequence. You can convert Parquet into rest of the other formats. So this is Overture data sets. Now, before jumping into the questions, I will showcase you a quick demo how you can process the data by yourself. I also gave you the demo how you can create a do your customized expert in expert tool. I gave you the demo how you can run your overpass query. You can also do expert in GeoJSON, GPX, KML from overpass server itself, or you can download them from GeoFabric, or you can download them from Planet OSM. There are also plenty of resources available around OpenStreetMap data, open data. I haven't covered them all. I tried to cover most popular ones. Now I will showcase how you can process your custom data or by yourself. So if you look into this, hold on, before going there, can any of you confirm my terminal is big enough for you to read? Yes? Can you see my terminal? Okay, perfect. Thank you, Miko. So if you look into data, what I did is I downloaded one Pokhara OSM.pvs from Expert Tool. So I went to Expert Tool and then I exported this Pokhara data in PBF format. This is the same PBF format you will get from GeoFabric, get from Planet OSM or any other services, right? Now I want to process this by myself. I want to put it in a QGIS. And then I want to run some query in it. Let's say I love doing query, special queries. And I want to use raw data API. That's it. Now it has a script called Python raw backend, and I will do insert. So underneath, what it uses is this. OSM to PGSQL. Those of you who are not aware of OSM to PGSQL, OSM to PGSQL is a command line tool that was written in C++, I think, that can convert OpenStreetMap data into Postgres and PostGIS database. So underneath, it uses OSM to PGSQL. I'll use the same, and I'll say, can you insert this data into my data sets? Before doing that, I will show you my database credentials. It's pretty simple, so I won't mind sharing. So I have a Postgres running in 5432 localhost. It's a Postgres. Now I'll export it and do insert. Now I'm running OSM to PGSQL. Now it is processing those node OSN relation. It is trying to translate those nodes OSN relations into PostGIS format so that they will have, geometries, proper geometries instead of, it will also have references, but it will also have geometries so that it will be very useful for me to load it in QGIS or do visualization on rest of the features, right? So it just take 19 seconds to load this, right? Now I will showcase my database to you first, which is this one, right? It's a local host. Now it created a bunch of tables. There is node, there is OS line, OS poly. OS line is basically all the line strings in OS poly, all the polygons in OS. There is a relation table. But here is the interesting thing. If you open it, you will get the geometry, right? So you'll get it will process it, it will populate the geometry. You can see the geometry from DWeaver itself, or you can use it like any other tools to communicate with your database. So I just processed it. I put it in my database, but what next? Like, what if I want to load it in QGIS, right? You'll have QGIS session separately later on, so I won't cover that part, but I will quickly show you how I can make this data useful in my case, right? So in QGIS, you have database DB manager. This is your PostGIS database. You need to make a connection for sure. So quickly testing up, you can do connection, set up your connection. I already did my connections. So I have my Postgres here. And if you look into this, I have all my tables. Now, good thing about this, what I can do here is I can open a SQL window and then I can simply shoot a couple of queries. Let's say, what if I want to have amenities, right? Let's say, okay, I want to have all the amenities in my area. Then I will say, hey, select tags amenity. Also select SQL from nodes. This is the table where tag amenity is not null. And then I can execute it, right? Let's say if I have nodes table. Okay. And then you can execute this query. Or good thing about QGIS, you can load this as a layer in your QGIS. I will showcase the query result. Those are all the nodes in my table. You can simply drag and drop, and those will be available in your QGIS, or you can export it in your different formats. Or you can have your query, the query that I did suit before. It only contains amenities, right? I won't go rest of the details on QGIS, but I just wanted to quickly show you how you can process the database data by yourself from .bbf. And then you can also process it using SQL for sure. And then you can load it in your favorite editors or something. So this is the quick demo how you can process the data. Now, I think, perfect. Questions? I'll stop here before handing the session over to my colleague.
Hi, Shatij. We have one question. Yeah, I think everyone, like everyone's very deep into the lecture. But Amaz mentioned and he asked, what is the benefit of using PBF as opposed to XML or SQL? Is it just the benefit of the size for better performance?
Yeah, so benefit of using PBF is size is definitely a benefit. Like size is definitely a benefit. The main thing where some developers opted for PBF is because of the size, and also it has a good performance as well. But not necessarily. Like let's say when you are processing SQL, because you don't need to convert it into PostGIS. SQL is already in a PostGIS format. So for PBF, you need extra layer there. You need to convert this PBF into the useful format. You need to decompress it, create a geometry out of it, and then populate. But it is still fast. That you have seen on my computer, I processed my city file in 19 seconds. So it is pretty fast, but it's not like if you load SQL, it will directly load. You don't need post processing. The downside of PBF, I won't say it's a downside, but since it's a compressed format, you need to still decompress and then read from it. Yeah. So if you notice PBF, like it will always have smaller file size, even though it's a whole country data. Yeah. Miko?
Okay, let me check. Let me double check. Yeah, we don't have any questions so far. Okay, yeah. So far, Kshitij, Amaz says thanks. And I think if there would be more questions related to visualizing this access of data, I think people could drop the questions via chat.
Yeah.
Thank you, Kshitij. And
Thank you.
Adityo, are you ready?
Yes, Miko. Let me share my screen.
Go ahead, the floor is yours.
I do hope that you already can see my screen, right?
Yes.
Yeah. Thank you. And first of all, apologize that I turned off my camera because there is a sudden power cut here. So yeah, I do hope that I present all of the material before my battery just running out. So yeah, hello everyone. My name is Aditya Wijananto. I'm with Kitich in the Tech and Data team. I work as an open data specialist. I start working with HOTS in 2012, but in 2021 I stopped working and joined again from 2023 last year. And right now I work as an open data specialist with the Tech and Data. So yeah, my part is how we visualize open map data because you know that previously you already aware about how to access open map data that's available outside there, which is specifically on OpenStreetMap, and then we have also Aperture dataset and also HDX, where mostly people share their dataset related to humanitarian and anything to there. And now we are moving to how we visualize OpenMap data. And before we start, I will talk about the concepts. I think some of you maybe you're already aware about this part. I saw this slide during presentation about UMAP, I think. So what makes good visualization? There are four aspects that makes a good visualization. First is the goal. Of course, this is very important part because to create a map or to create a visualization, you need to aware about the goals first. What is your goal? The what is your purpose for making a visualization? What are you trying to persuade? Are you trying to persuade government to make decision, or are you trying to inform the readers about the current situation? That's the goals that we need to set before making a visualization. And the second one, it's a data, of course. When we're talking about open metadata, we need we need to aware that all of our data set that we will use for visualization, we need to ensure that it's good enough. Uh, when I talking about good, it's more like it's already free from error, and you already quality check, and you already clean all your data set, so it's already ready to use. Because there's a term, known term, that garbage in, garbage out. So if you using garbage data, then you will produce a garbage result. So in order to create a good data, you need to make sure that the data that you put is good enough. Oh, sorry. In order to create good visualization, you need to ensure that your data are really good enough. And then the third part, it's about the story. You have goal and data. What story that you're trying to tell? What is the relationship between your data and the goal? Like, for example, you're talking about uh, the impact of earthquake. And then the goal that you are trying to convey to the readers is you are trying to understand how massive the damage of the earthquake. And the data that you use is the data from OpenStreetMap, which is building data that you already clean it. It's already free from error. All the data already represent the actual information. And then you're trying to inform the readers that this is the area that having massive impact from the earthquake. That's the story that you're trying to create. And then the last part is the visual form. It's obvious that the great visual plays the reader better. So we'll pass us to the next slide, which is take a look at this example. This is from Julian Hoffman in the Twitter. So he create a Great Fire of London, but using the current data set or modern data set in London. So the goals that he trying to convey is he trying to visualize the impact of Great Fire during 1666 with overlay with the building data that actual condition in London. So what we are what we are seeing here is we can see that this is the red one is the affected area of the Great Fire, and then this is very big because it's covered from St. Paul Cathedrals until the London Bridge and near to the Tower of London. So in this map, he's trying to convey that the inform the readers that this is the impact of Great Fire, and then this is the if we're talking about the landmark in London, you can see this is those are the area that affected. You can see the bank station actually affected by the Great Fire of London. And how about the next one? So this is actually, yeah, I myself is when I'm seeing this is too much color, and then I don't know about the goals. Maybe the goals that the one who create this is trying to convey the reader that this is the administrative area of Bogor city in Indonesia. But the creator is using a lot of color, which is in the visual part, it's not please the reader because there's too much color that affect in those map, and then it's it's impact the readers that to see this map. Or is this map it's too much for myself. It's too much because the legend also too much. You can see you cannot understand where is the green one. We actually having a lot of green here. Where is the purple one? We actually having a lot of purple. So it's confused the reader. So this is not a good map to visualize. I mean, if you want to visualize the administrative boundary, then you can just a single color, for example, and then you can just using labeling format. And when we're talking about visualize the map data, we're talking about visual hierarchy. And visual hierarchy is the organization of element within a design in a way that guides the viewer eyes. So in this geospatial visualization, the visual hierarchy is referred to ordering or ranking all symbol and elements in map. So we're talking about layers, like for example, point layers. It should be the first layer above everything. The the second one after points, it's like a line, and then after that, it's a polygon. That's the ranking or the order to showing. And then the concept of visual hierarchy is the contrast. It's essential factor controlling the element in visual hierarchy. Like for example, when we want to convey the reader that, for example, using this area, let's say the green one is the most populated area. Then what we can do is we can try to select only the green one, and then the rest of all administrative boundary, we turn it into gray, for example. So it will stand out, the green one, as a contrast to other area. And then we can say that the green one actually is the most populated area in Bogor. So things to understand, the first one, there is no good map. I mean, yeah, good is, yeah, everyone perception is different. We can say this one actually good because it's very informative, and this one is actually bad because it's too dark. I don't like the color. But we can also saying like this is bad and the one is good. So it's yeah, it's different with everyone, but only map that it's well designed and properly suited to audience, medium, and purpose. Like for example, what is our audience? Who is going to use our map? Is it novice, or is it a new mapper, or is it expert mapper, like the one who already aware about all the elements in map? And then about accessibility, for example, if your map support colorblind, if not, then you need to figure out like whether your map like color it support a colorblind people, for example. And then the time to spend with your map. If you spend too much, if you let reader spend too much to view the map, then actually it's good because your map is very interesting. Like for example, back again here, you can actually spend a lot of time here. Like okay, you can see there is Millennium Bridge here. This is London Bridge, and then there is a Tower of London. You can actually spend more time rather than this area, this map again. And then the medium, how will this map will be displayed? Is it for desktop? Is it for mobile? Or is it for printed map? Because every yeah, every medium, it's also affect how you create the map. Like for example, if you're talking about you want to create mobile version of yeah impact of earthquake, then you need to ensure that your labeling is good enough to be seen in mobile phone. And then for printed map, you need to ensure that your map DPI or your map sharpness it's good enough to print out in the like in printer or yeah, something like that. And then the purpose, it's about the goals again. What is the intended function of your map? Is it for navigation? If only navigation, then you don't need to add a lot of symbology or element. Like for example, is it for navigation? You don't need to add building data, or maybe you don't need to add place of worship. You can just actually add only critical element like a landmark around this area. And then is it for understand the spatial trend? Is it for emergency response, decision making, or something like that? So every map have different purpose, and depending on the purpose, your map also will visualize differently. And then now we're talking about tool for visualize map data. So maybe some of you already wonder like, what is the best tool that we can use to visualize our map data? And then the tools outside there, it's already too much. There are a lot of tools that offer capability to visualize your map data. Like, for example, S3 it's a popular, but it's paid. And for the free one, we have QGIS. And then there's also UMap, the one that you're already aware from a few weeks ago. And also there is a Kepler GL, and we have a Global Mapper, we have Felt, Mapbox. Yeah, the tools outside there, it's endless. And if you digging through the rabbit hole, you can get confused by yourself. So what I'm trying to convey you, like just using the tools that you already confident to use it, because if you're trying to learn all of this, it will overwhelm you. So that's why just use the tools that you can confident to use it. And then I will show some of the tools that actually we often use it, or sometimes people outside there often use it related to the OpenStreetMap and OpenMap data. The first one is OSMN. So I think most of you are already aware about what is OSMN. It's a navigation app that uses OSM as a base map. Actually, in the OSMN, you can also visualize your custom map for navigation. Like for example, you having like a custom map only showing building data, or like the road data that focus on the most impact, the most used road data, for example. You can actually upload it in OSMN. And then the second one is QGIS. Of course, most of you are already aware about this one. It's a free and open source software for geospatial analysis and visualization. And in QGIS, it provides you with several plugins that will help you to building a visualization. For example, we have a D3 data visualization, relief visualization toolbox, quick map service to download the OSM data directly, to using a base map layer, like a OSM base map layer. And we have quick OSM to download OSM data directly using Overpass Turbo. And then we have QGIS resource sharing to using a symbol that the other user already upload. And then we have hot templates and symbology manager. This is a new plugin that we developed. We're trying to ensure that people can generate map easily with this one. And then if you're aware about on the right side part, this is easy and advanced, and we have easy. This is relative like how difficult you're using this tool. So in QGIS, I put this as a I'm sorry. I put this as easy until advanced because it depends on your visualization purpose. It can be easy to use, but it can be very advanced to use. And we have actually a simple basic feature in OSM website, which is OSM export feature. You can export your map extent in osm.org as a digital format. Sorry. As a PNG, PDF, JPEG, and SVG by using this share feature in the OSM website. And also there is My OSMatic. It's a free web service that allow you generate maps of cities using OSM data. I will quick demo after this one. And also we have a Google Earth. Believe or not, most of government, like some of the government is still using Google Earth to visualize their data set. Like for example, here in Indonesia, for National Disaster Management Agency or Regional Disaster Management Agency, they use Google Earth to visualize the impact of like a disaster. Like for example, the earthquake, and they're still using the Google Earth. And this is most common use, and maybe some of you already use this. And then you can actually download RSM data using hot export tool, and you can download it as KML and load it in Google Map later. And then we have UMap, the one that we already aware from the last week session. And we have a Google My Maps. So it's actually it's also a common map that's easy to use by everyone, because it's a web-based mapping tool for creating a map by marking specific location. And also with this Google My Map, you can combine with the text or even like your CSV file or Excel or even like a KML file. Like for example, you are creating, I remember that back then in Indonesia, when Mountain Agung in Bali erupt, they using Google My Map to showing like this is the location of IDP camp, and this is the location of the command center, and those are the area that affected by Mount Agung eruption. So they using Google My Map because they say it's easy and they can develop quickly. So we can actually use the Google My Maps also to develop our maps. And we use it Canva. Yeah, I think most of you are already aware about Canva because you already have a session a few weeks ago. And actually, you can create a map using Canva. But of course, you need to combine with another JS software. For example, in this map on the right side, this is the one that I tried to create in Canva. I created in Canva. It's about movement area, movement maps, and it's about the Black Sea Grain Initiative and the Ukraine response. I create this movement map in QGIS, and for symbology, for styling, I created in Canva later. So it's like you combine those two tools to create maps like this one. And I think most of you already aware that using Canva, it's very easy. You can have a lot of elements that you can add. And then also some of the feature is free. You can use it and you can share it as a PDF or a PNG or something like a JPEG. And then the Overpass Turbo. So you might aware that previously it is saying that in the Overpass Turbo, it's also having the capability to download OSM data. But in Overpass Turbo, we also having like a capability to visualize the query as simple as like a showing like the label and then showing the location and then putting like a different color. You can actually use this in Overpass Turbo to develop a quick and simple visualization. And then we have Maperative. It's a free software to create your own map. You can load the map data from various sources, but mostly they're using OSM as a base data and export it to various formats. Like for example, in Bitmap. And actually, we used this for field survey previously, mostly to create MB tiles and then sometimes to create a bitmap or PNG to load it into mobile phone. But nowadays, we already have, a lot of tools can support to create MB tiles. We have QGIS, we have hot export to create MB tiles. So we already not use this anymore, but it's worth to inform that Maperative it's some of the tools that we used it before. And then the Kepler GL, it's open source geospatial analysis for the tools and visualization for large scale data set. So you can actually create a simple visualization using Kepler. And I will try to demo it later. And the difficulties is sometimes it's medium because for first time user, maybe you will overwhelmed with the layout. But if you already explore, then it's pretty easy to load the data. And also in the programming language like R, we also having like a visualization there. A lot of package to support visualization using R. Like for example, RCTs view, and then we have ggplot and ggvis or rstat that you can actually explore to create a visualization in R. But it's you need to learn first about R and also Python as well, because both R and Python, it's very popular programming language that you can actually create a good visualization from it. Like for example, in this Python, you need to adding another library, like for example, GeoPandas, Raster.io, Campy, or Volume. Yes, if you want to see more inspiration about how to create a good visualization, you can go to Twitter or X, search hashtag 30-day map challenge. It's very popular in November, in every November to celebrate JS Day. We often user in X or Twitter, it's conducting a 30-day map challenge. So they having like a various map challenge every day, and every day is different. So actually you can learn a lot from this one. And then you can go to repository to find out the entries from 2021 until 2023. Or you can check it online publisher like Visual Capitalist for reference, or even like join community for that data visualization practitioner or enthusiast, or check Portfolio website to get more inspiration. So I will try to demo a quick demo about how to visualize, and I'm not going to visualize using OpenStreetMap. I'm going to use my OSMatic, because it's very easy. You can just create a map, and then you can go to your area of interest, like for example, Karta here. And then you can just click next. Then you can choose layout. Do you want to index or without? And if you want to index in the bottom, it will showing a temporal visualization on the right side. Then you can check next. What is the style that you want? Is it humanitarian, or it's like a if you want to using, yeah, you can choose a lot of visualization here, like for example low contrast, and then you click next again, and you want to overlay with decoration like scale bar, UTM grid or not. Select your paper. Do you want to create A3 or A4? Then you can click next, and then you just write your title and then generate. Email address is optional, so it will generate map, something like this one. So this is the map that created from my OSMatic. So it's very easy and very quick to create digital map. And then demo about how to use Kepler. And if you go to the kepler.gr/demo, the first one is you can add data to map, or if you don't have data, you can try to sample data. I will try to use data from HDX, which is related to population data. So you're just adding your GeoJSON data from HDX. You download from HDX population data, and then you can visualize it in Kepler. Like this is the color that if you want to use this color or not, you can select color based on population, and it will change into like the darker one is the one that already having like a most populated area. Oh no, less populated area. For example, like this one. And yeah, you can play around with this. You can adding more interaction. Like, do you want to having like a coordinates, or you just want to have a geocoder, or if you just need to add brush or not. And then you can just put it share as a map URL. Then that's it. It's you need to share map within this. You need to having this kind of account for Square Studio, Dropbox, or Carto. But if not, you can just export it as image. And this is Canva, the one that I create. So you can see here, this is the one that I create. This the text. It's created by Canva, but the rest, like the flow map, it's using QGIS. And yeah, question?
Let me check. So currently, Aditya, there's no questions. Feel
Okay.
free. Okay, we have one from John Gabriel. What will be the latest year that the map will be shown?
Which map? Sorry.
Can you please elaborate, John Gabriel? Feel free to chat.
Is it related to my OSMatic? I think if we're talking about my OSMatic, it's based on the current OSM data status. Like for example, if you're adding a lot of data in OSM, then you can just wait until it refreshes, and you can just go to this website and then you can start to create.
Aditya, John Gabriel mentioned that for the sample maps, it is 2024 map. Question mark.
The sample map, this one, yes, it's using the current data set, the 2024 map.
So it pulls out the latest data when you
Yeah,
run it.
yeah, it's the latest data because if you go to the Semantic, you can the JS database platform status. It's update according to OSM data. So yeah, it's matched with current OSM data state.
Okay. Yes, I think that, well, yeah. Someone, Jalal is asking, Aditya, can you recommend tools similar to Kepler GL that can handle very large data sets? Like I work with government data sets that are sometimes very large in size.
Uh, Maybe Kitits can adding for this one, but yeah, to my knowledge, you can use actually using PostGIS and combine with Kepler or QGIS. So Kitits, do you have any suggestion for this one for handling large amount of data set?
Yeah, there is one tool which is very popular is nowadays is called Longboard. It's developed by Development C, and it has the ability to handle like huge data sets. So Longboard definitely, or what I recommend is converting your data sets into file format that has indexes. For example, flat GeoBuff, GeoParquet, Aerofile. Those are the, and also GeoPackage. So those type of data file formats will have can support special indexes. So you can actually only render some part of it, and or like render everything, and it will render smoothly. And if it is only not only about it is only about rendering, you can make use of vector tiles. There is another tile called TM tiles which you can use, or MB tiles. If it's not only for rendering, if you want to do analysis, as I mentioned before, you can make use of file formats which has indexes in it.
So yeah, there's a lot of tools that you actually can use to process a large data set.
I think on the other note, there's another question that is asking for suggestions for any applications that is easy to use and to make a minimalist style map for large areas. For example, country maps only showing boundaries.
Well, I would suggest that you can use Kepler to visualize it, but you need to prepare your data set, like using hot export or even like an overpass or HDX to unload to only download the administrative boundary, and then you convert it into GeoJSON, and then you load it into Kepler GL. So it's easy to use. You can just load it into Kepler GL, and then you can just visualize it later. Oh
Yes.
yeah, Kit.
Yeah. Also, one top of it is I forgot to showcase SDX. Maybe I can quickly show is this. So here you can also find it's a data sets like administrative boundaries. SDX is a tool developed by OCHA. It's called a Humanitarian Data Access Platform. It contains a special and non-special data where you can actually find, let's say, administrative boundaries, or like HotOSM is also very active in SDX. So yeah, you can get all the subnational boundaries, maybe some national boundaries, and then it has multiple file formats. Let's say download GeoJSON from here, load it to the Kepler directly. And also, or you can get those administrative boundaries from Hot Expert tool. If you go here, let's say if I want to have administrative boundary for my city, which is this one, I just want administrative. And then I want it in GeoJSON. And in data, you can collect administrative boundaries, create expert. After a couple of minutes, you will get the data. You can visualize it in Kepler or UMap. Kepler is very easy to visualize those and create a map, or in UMap for sure. In SDX, in organization, if you search for HotOSM, you will also find some like data sets that are published by HotOSM. And then you can download it in different file formats. Let's say for Oman buildings, it has polygons in shapefile, KML, GeoJSON, and GeoPackage as well. It also has a small visualization that can do visualization in this area. I think it will work for other data sets as well. So like this administrative boundary got completed. And if I download it and open it in my Kepler, I can quickly create a map. Okay, this is test. I will download it. And then you can simply unzip it. There you go. Flash all. So the files. Yeah, and then drag and drop. So I have all the administrative boundary in my area. Now, if I do not fill those, so this is my country boundary. This is my province boundary. This is my municipality. This is a smaller one. And it will also have name and everything if you want. And those are my ward boundaries. So yeah, you can create a map from here now. So this is how easy it should be. If you know the resources where you can get them and type of the file formats. Thank you.
Thank you, Shatij. Thank you, Aditya. So I don't think there are any questions anymore. I will be proceeding for the final announcements so that we are able to also wrap up this very interesting. And I was exploring some of the tools you were mentioning and playing around already. So let me just go ahead and share my screen. So some announcements. So first and foremost, please do answer the attendance forms. It's already shared via chat. And make sure to answer them if you want to receive the e-certificate and also the links and slides from our presentation and the recordings for this training session. So please do answer the e-certificate form or the attendance form. Similarly, as a show of thanks and support for our trainings, we encourage everyone to share feedback or say thanks to our trainers, Adityo and Shitij, via the learning feedback form. We would want to continue on this very interesting topics and more deep dive on the tech tools that we have in the open mapping field. Uh, and so please put in your feedback form. So I'll just go through very quickly with some announcements. So we also still have 2 more trainings coming up. The intro to basic QGIS analytics. So from data acquisition or accessing the data to visualizing the data, we're now going to do a deep dive with John Bryant of Mammoth Geospatial to do an introduction to basic QGIS analytics and QGIS for specific use case scenarios. So I'm going to share the link afterwards for the registration. So I think if you registered in this link, you might have access to that link. It's the same link, but you need to tick on the box so that we could send you the calendar invite. So we also have trainings from our open mapping gurus this coming days. So it's more on these trainings are more on deep dives into different open mapping tools. So we have JOSOM validation training on the 20th of April and a QGIS intro to mapping using QGIS on the 20th as well. So feel free to register. It's the same link as the tech tools that tech trainings we're having right now. Similarly, like if you have free time, feel free to map with us in our scheduled mapathons. This April, we have one for Papua New Guinea earthquake. We have the Oceania, Vanuatu, Micronesia, Tonga Mapathon. We also have one in the Philippines for Dinalungan and the Gapela in Bhutan. So please do register. These are remote training sessions and you'll be mapping together with experienced and enthusiastic mappers throughout the region of the Asia Pacific. So feel free to register. I'm going to share the link also in the chat. Also, like these are tasks that are still open that we would want to continue on mapping and updating the building footprints and roads in Tonga, Vanuatu, and Micronesia. So these are areas most at risk with the effects of climate change. So feel free to support in the mapping. More mapathons and mapping activities that are happening right now in the region. So we have the Papua New Guinea earthquake and the Taiwan earthquake. So feel free to visit Tasking Manager, search for keywords Taiwan or Papua New Guinea, and the projects will be appearing there. If you are more of a mobile app user, feel free to download MapSwipe and you'll be able to help in the mapping, cut down the time for mapping the areas with buildings. So feel free to just swipe in your free time. And lastly, if you are part of of a civil service organization, NGO, or the academe, feel free to reach out to me. We can provide a free 1.5 hour or 1 to 2 hour mapathon with your team so that we could introduce OpenStreetMap, open mapping to your organization or academy. Feel free to join the Hot OSM Slack channel. It's here. If you want to reach out more with Shitij and Adityo, they are all there. Everyone's mostly there. And you can, reach out and contact them. And Shitij is sharing his email if you have any more questions. Similarly, Lean Dion isn't in joining the call today. But if you have more tech questions or needed support in the open tech field, feel free to reach out to Lean Dion and or through the Open Mapping Hub Asia Pacific at hotosm.com. So pretty much that's it. I'm just going to share the links for the registration page and we can wrap things up. Hopefully you have more questions. So for trainings and mapathons, we've separated them out. Here you go. Stop presenting. And I'll be stopping the recordings now. So all the trainings and mapathons I shared, you could register here and we will invite you via calendar. Thank you very much, everyone. Have a great evening in front of you. And thank you, Kshitij and Aditya.
Thank you, everyone.